Today's video, we are going to see the size and the nature of the image with a concave mirror. This is a concave mirror and this is the principal axis. The focal length of the concave mirror is 20 centimeters. Let us try to keep an object here at a distance of 30 centimeters from the pole of the mirror. To find the image of this, we need to calculate the relation 1 by f is equal to 1 by u plus 1 by v. We do not know the value of v. We know that the focal length of a concave mirror is supposed to be negative, and so we need to write this as minus 20. You are able to see that this is how the rays travel, and I call this as a positive, but the distance is calculated in the opposite direction, so the object distance is going to be minus 30 and this is supposed to be plus v. So 1 by v becomes 1 by 30 minus 1 by 20. We got to see here this is 60, this goes 2 times and this goes 3 times. So 1 upon v is minus 1 upon 60 and so v becomes equal to minus 60 centimeters. That means the image is formed somewhere here at 60 centimeters from the mirror. How is this formed? We are able to see that the ray which travels, which is going to get reflected, is going to meet here at this place. So this is what we are able to see, and so this is how it goes. Let me try to draw this in a proper way like this. It goes. So this is what it is. And the next one is a ray of light which hits the pole has to again go and strike here, and so we find the image here. So the image is going to be inverted and the image is a real image and it is formed 60 centimeters from the pole of the mirror. Let us try to understand the optical power of a lens. What do we mean exactly by optical power? If power is positive, what does that mean? Power is negative, what does that mean? Power is zero, what does that mean? Let us try to take one convex lens here. This is supposed to be a convex lens and whose focal length is supposed to be 20 centimeters. That tells you that if there is a ray which is trying to travel from a distant object, if this is what is called the principal axis, the rays are going to converge to a point that is 20 centimeters from the optic center of this particular lens. In fact, this is the place where the image is supposed to be formed, and this image we call it as a real image. Now we are able to see this ray should have gone straight, but it is deviating by certain angle. I call this angle as theta. Similarly, this ray is getting deviated by the same angle theta. So the rays are getting converged, and hence this lens is called a convergent lens or a convex lens. In such case, the power is said to be positive. The power is positive. We call this power as measured in diopters, and so we put 100 on the top and say the focal length here, which is put in centimeters. Power is nothing but the reciprocal of the focal length, which is measured in meter. So how did we convert that to meter? 20 centimeter divided by 100 has been turned into meters. So I think this will go here 5 times, and so we call the power is 5 diopters if it is a convergent lens. It is plus. And similarly, if it is supposed to be a concave lens, we call it a divergent lens, and the power should be negative because the rays are being diverged instead of getting converged. In this video, let us try to calculate the linear magnification of the image formed due to a concave mirror with a certain parameters. I shall fix the parameters so that it becomes easier now. This is supposed to be a concave mirror, and this is having a focal length of say 20 centimeters. You kept an object here, so that is supposed to be 30 centimeters. You kept an object, and this is supposed to be the pole of it. Imagine that this is supposed to be 2 centimeters. This is supposed to be the height, which is supposed to be 2 centimeters. We just now got that if you try to take the ray diagram of this, then you find that the image goes this way, and this ray is getting reflected at the pole, and it shall meet here, and so this is supposed to be the image of this. So the image is formed at 16 centimeters from the basic relation 1 by u plus 1 by v is 1 by f. 1 by u, you can call it, because the object is kept at 30 centimeters, you call it as minus 30. You have no clue about the image distance, and this is called as minus 20 because focal length of a concave mirror is negative. And so we can say 1 by v is 1 by 30 minus 1 by 20, and so you get this as 1 by 60. In fact, you get this as minus, so v is minus 60 centimeters. What does the minus say? That this is the direction we choose it as positive because the incident rays travel here, but image distance is calculated from pole to the location where the image is formed. So you are going in opposite direction to the positive, and hence it is negative minus 60 centimeters. We are trying to speak of the linear magnification, and that is supposed to be minus of v by u. That tells you minus sign, you leave it aside. V you got it as minus 60, and u you got it as minus 30, and so this is minus 2. What does the minus say? Linear magnification is minus 2. That means the size of the image is double the size of the object. Minus sign tells you that it is inverted. So this image is a real image, it's an inverted image, and it's a magnified image. So these are what it is: a real image, a magnified image, and it's a inverted image. Where is it formed? 60 centimeters measured from the pole.